So for those of you who are just joining us, we're doing the warm-up problem on the board. So LeBron James, he just dunked a basketball. And so when the basketball hoops around a height of 3 meters, and a basketball has a mass of 0.625 kilograms. So I want you to figure out the potential energy, the kinetic energy, and the total energy at this location. On the board, I have a bunch of stuff to help you figure it out. And so after a second, we'll work through it together. Yeah, so to start off with, so you can work through the whole thing if you're feeling quick. If you want to start off with, we can first also start off with identifying what are the things we're given. So I'm telling you right now that we are given our velocity, but there's three other things that we're given. So I want you to tell me the names of the things we're given, and then I want you to tell me their values for each one. So let's take a minute to do that in the Zoom chat. What are the quantities we're given, and how much of each are given? So let's get a few answers in the Zoom chat. We got 22 people here right now. So can we get 5 answers? We got Hannah. Great work, Hannah. Hannah's doing a great job of telling us. We're given a mass. What else are we given, though? We are given a few other things. Can someone contribute something as well? We don't want to leave Hannah hanging here. We got George. Great work, George. And then I think there's one other thing that is always given to us that is very, very, very important. One of the things that is very important to us. What else are we given? Okay. So to start off with, what we're going to do is we're going to just quickly write down the things we're given. So we are given a mass of 0.625 kilograms. We are also given a height, 30 meters, and we're given our gravity, which is 10 meters per second squared. Now, I've also told you that we are given a velocity. Does someone know what velocity we're given? What is our velocity? So I told you that we're given a velocity, but I haven't told you the number. So what is our velocity at the very beginning? Right as the basketball starts falling. Right as it starts falling, at the very moment you put it through the hoop, how fast is it moving? Right at that very instant. Anyone have any ideas? What is the velocity of something right as it starts falling? Like at the very moment you let go of something. Anyone have any ideas? Okay, so this is very important. Definitely something you should write down. At the moment something starts falling, it has a velocity of 0. And this is right as it starts falling, it has a velocity of 0, right? If I'm holding something and I'm let go of it, at the very instant I let go of it, it hasn't quite started moving yet. And so it has a velocity of 0. Okay, so now that we have identified all the things we're given, what we're going to do now is we're going to fill in the things we're looking for. So what I've told you in the problem is I've told you that we're looking for potential energy. I told you that we're looking for our total energy, our kinetic energy, and I also told you that we're looking for our total energy. Okay. So now let's figure out which equations we want to use. So in general, there's a few equations here that are going to be very helpful. Okay. Equations. So one of them is going to be the equation for our potential energy. Mass times gravity times height. Another one is for our kinetic energy. 1/2 times m times v squared. And the last one is for our total energy, which is our potential energy plus our kinetic energy. Okay, so I filled in these 2 steps now. But now what I want you to do is I want you to substitute everything here. And then I want you to tell me what you get for our potential energy, kinetic energy, and our total energy. So let's take a minute to do that. Let's see what I get for potential energy. We got a couple answers so far. Can we get a few more? Can we get a few more answers? And does anyone want to show us how you substitute something in? How did you substitute for your potential energy? A couple answers. So we got three answers so far for potential energy. We got one for kinetic. Does anyone want to show us how they substituted for their potential or kinetic? And does anyone have any answers for the total energy? Also good. We got George. Great work, George. Can we get a few more answers in here? We got Miguel. Great work, Miguel. Let's take another minute or two to try to substitute things in. Well, I got Caitlin showing us how we substitute these things. Great work, Caitlin. We got Claire. Let's take another minute or two. We got Jose. Great work, Jose. We got Hannah doing a great job of substituting her numbers in. Doing a great job of showing us how she did it. Thank you, Hannah. And I love how you label your units too. That's a really good job. We got Claire. Good work, Claire. We got Miguel, the total energy. Nice work. Okay. So what I'm going to do is I'm going to just show you how you can substitute these things in. So, okay. So let's substitute things in for potential energy. We don't know our potential energy, but we do know our mass, which is 0.625. We know to multiply by our gravity, which is 10, and we can multiply by our height, which is 3. And so this gives us a potential energy of 18.75 joules. Okay, so our kinetic energy, because our velocity is 0, our kinetic energy is just going to end up being 0. And if you think about it conceptually, if something is not moving, it's not going to have any kinetic energy. So we don't even need to fill in anything here. We just know that our kinetic energy is going to be 0 because it's not moving. And if something is not moving, it has no kinetic energy. And last but not least, let's just add our potential energy to kinetic energy to 18.75 plus 0 is just 18.75 for our total energy. Does anyone have any questions about how I did that? Okay, so what we're going to do now is we're actually going to extend on this problem. We are going to add in another problem that's going to build off of it. So that is at the moment I first drop it. What I want to know now is how fast is it moving right as it hits the ground. This is actually a very important concept. It's something that relates a lot to a roller coaster, is how fast something moves after it falls. So what I'm going to do is I'm going to write down our little setup here. Guess, and then we want to figure out, okay, what are our knowns? What are some of the things we know? What are some of our unknowns? What are some of our equations? So what I'm going to do now is I'm going to give you a little hint on some of the things we know. So right as it hits ground, I'm going to tell you right now that we already know our total energy. And then I'm going to say, okay, I want you to fill out the rest. So let's see if we can fill out that top row. What are the quantities we know, and how much of each do we know? Okay. We know our total energy. What else do we know in this problem? Great work, Hannah. Miguel, see, do you know how much of each we have? We know mass. Great work, Tracy. Great work, Rebecca. We're building off of Tracy's answer. Great work. Take another minute or two to see if we can fill in these things in. Does anyone know so does anyone know what, so we want to figure out what our kinetic energy is and our potential energy is when it hits the ground. That's so that we're no longer on the top, at the top of the hoop. We are on the ground now. We hit the ground. So we want to think about that. Yeah. So I also wrote down that we know our total energy. Does anyone know what our total energy might be? It's a challenging concept, but we do know our total energy. We don't actually need to calculate it. Anyone have any ideas? So what I'm going to do is I'm going to fill in some of the stuff that we know. So we did a great job here. We know our mass, 0.625. We know our height. So Caitlin has told us that we actually know our total energy. So this is a very important concept. We don't need to calculate this total energy because we already did so here in this bottom right corner. So all we did is we just took our total energy all the way back here. So all we did here is we took our total energy, which we already calculated before, and we just brought it all the way over here. Because the total energy in this basketball is always conserved. It always stays the same. So our total energy in the bottom right here goes all the way back here into this top. So we already know our total energy here. We don't actually need to calculate it. Okay. So exactly, Hannah. Total energy is never destroyed, so our total energy has to be the same. Okay. So there's a couple of other things that I'm going to say that are also important. We also need to know what G is. G is always 10 meters per second squared. Okay, and then I'm going to tell you our height, because remember, the ball has hit the ground now. It is no longer on the top of the hoop, it has hit the ground. So when it hits the ground, it has a height of 0 meters. Okay, so the unknowns of this problem, so we need to find our kinetic energy, and we need to find our velocity. So those are things that we're trying to find. But in order to find our kinetic energy, we're also going to need to find our potential energy. This can be kind of tricky. I think in general, it's always good to figure out all the unknown quantities. I think I should have said we also need a potential energy here. So what I'm going to do now is I'm going to write down our equations that we need to use. So PE is equal to M times G times H. KE is 1/2 times M times V squared. And then I want you to find our total energy. Oh, our total energy is also potential energy plus kinetic energy. So now we need to substitute and solve for these things. So why don't we take a minute for you to plug in some stuff and see if you can solve for our kinetic, our potential, and our velocity. Ooh, nice, Jose. Jose, it's a great explanation. Let's see if we can get some more answers. Jose's got a great answer. Can we figure out our potential energy? I think our potential energy is going to be the easiest one to figure out here. And maybe you can figure out why potential energy is going to be the easiest. We can also figure out kinetic energy from that. Ooh, Hannah, great work. Figured that pretty easy. Great work, Hannah. Let's see if we can figure out our kinetic energy too. Good question, Hannah. And so what I want you to think about, Hannah, is think about that our total energy always has to add up to 18.75. So our total energy is our potential energy plus our kinetic energy. And because we found out our total energy earlier, which is 18.75, our total energy has to be 18.75 here. So we need to make sure that our potential energy and our kinetic energy, they both add up to 18.75 here as well. So if we know one of them, we know that the other one plus the first one also it has to equal 18.75. So how would that change your answer, Hannah? Oh, nice. That's very, very, very clever, Hannah. Great work. So we got a couple answers so far. We'll take another couple minutes or so to see if we can keep working on this. Can we figure out our velocity? The velocity part, that's a little bit of tricky algebra. So I'll make sure to do it when we are going through this. Anyone have any answers for our velocity? What I'm going to do here is I'm going to start solving for our. So first I'm going to do is I'm going to take down what Hannah said. So what Hannah really did a good job of recognizing here is that our height is 0. So if we bring our height down here, for height is 0, our potential energy also has to be 0. Right? In other words, if an object is on the ground, it has 0 potential energy. This is a very important concept. Potential energy relates to an object's height. So if it's on the ground, it has 0 potential energy. Okay, so let's talk about our kinetic energy then. So I'm going to again use Hannah's deduction here. She did a really good job here. And so she realized that, okay, our total energy has to be conserved. So our total energy has to be 18.75, right? It was 18.75 here. It has to be 18.75 here again. Okay, and then we also realized that, okay, hey, our total energy is our potential energy plus our kinetic energy. And since our potential energy is 0, right? So if we substitute in 18.75 for our total energy, 0 for our potential energy, we'll get that our kinetic energy is just 18.75 again. So potential energy is 0. Our kinetic energy is 18.75. Now what we're going to do here is we're going to do the hardest part of this. We're going to substitute our kinetic energy to find our velocity. Okay, so what I'm going to do is I'm going to do this algebra problem on the left here. And I'm going to hide it on this one here. Okay, so what I'm going to do is I'm going to do this algebra on the board. So our kinetic energy, kinetic energy 1/2 m times v squared. So hey, Jose has a really good explanation for this. What Jose realizes, okay, our total energy is 18.75. He knows that our mass is 0.625. We don't know our velocity. So Jose was like, okay, I'm going to multiply these together. 1/2 times 0.625. This is 0.3125. And then what Jose did is he just divided both sides by 0.3125. We got that our velocity squared is 60. So this part right here is okay, right? All we did was we just combined like terms. We divided out the 0.3125, and we get this nice number, 60 is equal to v squared. This is not our answer. Our answer is not 60. Why is it not 60? Because this velocity is squared. We do not want a squared answer here. We want our actual number. So what can we do to get rid of the square? Well, the operation we use is the square root. So square root of 60, get square root of v squared. And so we get that our velocity is 7.75 meters per second. So this part right here, this square root step, can be very challenging. And so I'm just showing you how we can do it. And our velocity is 7.75 meters per second. Okay, so now we're going to expand this problem one more time. One more time, what? No, Mr. Who, you can't do that. No, we can't do that. And it's because we're going to do one more little problem where we're going to continue where we picked up on. Okay, so now what we're going to do is we're going to find our potential energy, our kinetic energy, and the velocity of the basketball after it bounces back up to a height of 1 meter. This is the hardest problem out of the three, and this is something that you've probably seen a lot in your roller coaster. This idea of, okay, something went up, went down, and then went back up. How much energy does it have at that particular location? Okay, so let's see if we can. Let's take 5-10 minutes to see if we can figure this out. How much potential energy, how much kinetic energy, what our velocity is at this point. So I'm just going to erase this just to make more space. So it bounces back up to a height of 1 meter. So that is very important. Again, I want to identify the things that we don't know. Things that we know. So whenever you're ready in the chat, I want you to start identifying some of the things that we know. Just right off the top of our head. What we know. I mean, very similar to what we just did. We're going to know, believe it or not, we're actually going to know a lot of things already. So what are the 4 things we already know? 4 things that we already know from the problem. Let's get some answers in the chat here. Let's get some answers in the chat. There are 4 things we already know. What do we know already? Okay, so I'm going to fill in some of these. You know, gravity, which is 10 meters per second squared. Notice how this is always the same, regardless. We never actually calculated it. Our gravity is always the same. Then we know our mass, which is 0.625. We know our height. Our height is 1 meter. We know our total energy. What is our total energy again? Does anyone know? Is it 5? Is it 20? Is it 30? No. Jose knows. Jose was at George. Let's see. Hannah knows that our total energy is just 18.75. All right, so this is very important. Even though the roller coaster, the basketball is going up and down, our total energy is still the same. So our total energy was 18.75 here. It's 18.75 here. It's 18.75 here. Okay, so now we're trying to find our potential energy, kinetic energy, and our velocity again. So we're going to use our equations, PE into M TH, KE is 1/2 mv squared, and total energy is kinetic energy plus potential energy. So now I want you to solve for our potential energy, our kinetic energy, and our velocity. This is going to be a lot harder than the last one, but the conceptual idea is going to be the same. So I'm going to give you a little bit more time to do this work. Just substitute some stuff in, see what you can get. Whenever you're ready, you can put some answers in the chat. Did anyone get an answer for our potential energy? Anyone get an answer? What do we get for our potential energy? Do this, we're going to take our potential energy. We're going to take our mass, which is 0.625. We're going to multiply by our gravity, which is 10. Multiply by our height, which is 1. We're going to get our potential energy is 6.25 joules. So to figure out our kinetic energy, what we're going to do is we are going to subtract our kinetic energy, our potential energy from our total energy. So 18.75 minus 6.25. So we took our kinetic energy. So this is 12.5. And then to solve for kinetic energy, what we're going to do is we're going to do 12.5 is equal to 1/2 mv squared. 25 is equal to mv squared. 25 over 0.625 v squared. And then if you do this, I think v is like 6.3. 6.3. Okay. Nice, nice, perfect. Does anyone have any questions about how I did it? I think seems like a lot of you got very similar answers, which is very good. Anyone else have any questions about how we did this? These concepts can be challenging and they're very important because when we look at a roller coaster, we need to be able to determine whether or not those energies are accurate. You know how it even works. Okay, so what we're going to do is we're going to pick up where left off last week. We're just going to keep working on part 4. If you haven't done so already. Hopefully, hopefully a lot of you have started moving on to part 5. If you have finished part 4, just send me a message so that way I can sort of explain what we're doing for part 5. Otherwise, just keep working on part 4 and I'll try to answer any questions. Yeah. So go ahead, yeah, keep working on part 4 of the roller coaster, where we do a lot of calculations. And then I will start getting ready to explain part 5. So, hello everyone. We have 2 minutes left in class, so what I'm going to do is I'm just going to wrap up. So, what you need to have done by Wednesday. So, on Wednesday, you need to submit your part 4. If you haven't submitted part 4 already, you need to submit part 4 for however far you've gone. It's okay if you finish all of it, but you need to submit part 4 for participation on Wednesday. Odds are there's going to be a lot of no participations on Wednesday, but all you have to do is you just submit wherever you are. If you didn't finish it, that's okay. Just submit wherever you are. Otherwise, I won't give you participation for the week. So it is very important to do that. I want you to try to finish part 4 by Thursday because we will formally start part 5 on Thursday. So I want you to try to finish part 4 on Thursday. I highly encourage you to come to office hours. They've been very helpful for a lot of people. So I do want you to try to encourage it. So otherwise, if you don't have any other questions, I'm just going to let you out a minute early. Yeah.
Thank you, Mr. Hu. Have a good day.
You too.
Okay, Mr. Hugh. Bye.
Bye-bye.
Thank you. Bye.